Good morning, everyone. All right, so we are starting our Unit 4, which is all on rational functions. And what are rational functions? And the easiest way or the best way to think about them, in my opinion, is if you think about a rational number versus an irrational number. Okay, the big difference between them, irrational numbers will go on forever, never repeating, and they can't be written as a fraction. Huge, cannot be written as a fraction. Whereas rational numbers can be written as fractions. So when we're talking about rational functions, you're talking about functions that are in the form of some polynomial over another polynomial. Okay, remember, polynomials could be a monomial, so a number, a variable, a combination of the two. Could be a binomial, trinomial, and so forth. Okay, so we're looking at just these polynomials written in fraction form. So fractions, things we got to think about. If we're adding and subtracting them, they need common denominators. If we are multiplying them, we multiply straight across the numerator, straight across the denominator. If we're dividing, then you need to keep the first fraction the same, change the operation to multiplication, and then take the reciprocal of the right fraction, and then multiply across the numerator and multiply across the denominator. So all these things are applying to our rational functions because they are in fraction form. And the one thing that we do need to watch out for is that what can't be in the denominator? Dun, dun, dun. You can't have a zero. So when it says find all the values that make each function or expression undefined, right here, this guy, they're called restrictions. And basically what that is where the denominator is equal to 0. It's a restriction because that value that makes that denominator equal to 0 can't exist within your expression or within your function, depending on what you're looking at. So if we look at example number 1, in order to find the restrictions, we're going to take each piece in the denominator and set it not equal to 0. Okay, so x can't be -1. X squared can't be 4. So I'm going to take the square root of both sides. Oopsies, that means my square goes away. I'm going to take the square root of both sides. And if you take the square root of both sides when you're solving, that means you have a plus and minus. So x can't be -1 or plus and minus 2. There are 3 restrictions on this particular rational function. Okay, so then the second thing it asks us to do is simplify. Notice I did it in reverse order. You have to always find the restricted values first. Because once you simplify, you might take away a restricted value, and therefore you're not going to have all of them listed, just like when you're solving an equation. Okay, so let's go ahead and cancel from the top to the bottom. Well, I see that I can continue to simplify the denominator. So I'm going to go ahead and factor out x squared minus 4. It's a difference of squares. I'm running out of room. Okay, and then from here, see if you can cancel anything from the numerator and the denominator. And it looks like just x plus 1. I should have done this better with my spacing, sorry guys. So then if I cancel those out, I'm left with 2x in the numerator, followed by x plus 2 over x minus 2, and that is simplified form. Okay, so remember, you have to first find the restricted values, and then you can simplify. So for letter B, let's go ahead, you know what, let's go ahead and simplify everything out first. Let's factor out some greatest common factors. It doesn't look yet like we can factor any binomials or trinomials. So let's factor out an a to the third in the numerator, and that leaves us with 3 minus a. And then in the denominator, we can pull out a 2a squared, and that's going to leave us with a minus 3. Okay, from here we can go ahead and find those restrictions. So there's 2 pieces. I'm going to set my 2a squared not equal to 0, which means a can't be 0. And a minus 3 can't be 0, so a cannot be 3. Therefore, I'm going to write it together. A cannot be 0 or 3. Those are our restricted values. And then I'm going to go back and start canceling from the numerator and the denominator if there are things that we can. Well, there's 2 a's in the denominator and 3 in the top, so we can certainly reduce that. And that's going to leave us with a times 3 minus a all over 2 times a minus 3. Now I notice the binomials are very similar, but the signs are different. So I'm going to factor out a negative from that first one, or the numerator, I should say. And in doing so, that's going to change my signs. Why would I want to do that? So that I could simplify. If you come across something similar to that, then you need to factor out that negative so that the signs become the same and you can reduce. You could multiply the top and the bottom by a negative, yes, but that's excessive. You want to factor out the negative so that the signs change in the binomial in the numerator and they can be the same. And then we are done. Okay, so we simplified first here, which was a little bit different than on example A. It doesn't matter what order you do it. Sometimes it is better to simplify first and then find the restrictions because it helps you in the long run for when you have to cancel. Okay, if we look at C, nothing to factor. Okay, so let's go ahead and find the restrictions first in the denominator. For this, since nothing's being added or subtracted, we simply need to know that 5b squared can't be 0. So ultimately, b can't be 0 if we were divided by 5 and then take the square root. Also, c can't be 0. So those are our 2 restricted values. If we then try to simplify from the numerator and the denominator, 2 and 5, they don't have anything in common other than 1. A squared, b squared, c, this is in simplified form. I know, you guys love those the most. Okay, D is something definitely a little bit different that we haven't seen. Yay! And it is dividing. And it's different because we're seeing now that we're going to multiply. Haha, why are we multiplying? Because it's dividing fractions. So make sure, well, I got to make sure I'm on the right color. Okay, make sure that we keep the first the same. So we have 8x squared y over 15a squared b. Change the division to multiplication and then take the reciprocal of the right-hand fraction. Why? Because we are dividing fractions. Okay, so what this says is I'm going to multiply straight across. Everything that's in both of the numerators is going to be multiplied together. And everything that's in the denominators is going to be multiplied together. So yes, it does look like a kind of a big old mess when you write it like that. You can multiply the constants together if you would like. I chose not to because I know that the 2 and the 8 can reduce, and I know that the 5 and the 15 can reduce. I also know that the x and the x squared can reduce, the y and the y squared can reduce, the a and the a squared, and the b and the b to the 4th. Okay, notice as I'm doing this, I'm using a different color because there's a lot going on in this one, and so the different color helps me to see, okay, so in the numerator, I have a 4, an x, and a b cubed. And in the denominator, I have a 3, an a, and a y. Okay, if you keep the colors the same, it's a lot easier to get messed up with everything and maybe forget a letter or multiply something that you've already canceled but you couldn't see it. So at the very end, I'm going to look. Okay, 3 and 4, no, greatest common factor is 1 I've reduced. In the numerator, my variables are different than that of the denominator, so I have simplified fully. All right, for the try these, what I'd like for you guys to do is pause this video and then do just that. I want you to try these. However, I only want you to simplify them, okay? Only simplify. Did you pause it? Did ya? Don't lie. Okay, so hopefully you did, and my directions were to just simplify. So for A, you should have y to the 4th over y minus a. Remember that your goal, or sorry, not your, well, your goal is to simplify, but remember that if you are multiplying common bases, same bases, you add their exponents. Okay, for B, you should have 7b over 5a. And then for c, you should end up with 16c in the numerator, 15m squared nd squared. Some teachers prefer alphabetical variables. I really don't care as long as they are in the right spot with the right denominator, or with the right exponent. Okay, so in the right spot, right exponent. All right, last but not least, oh, check out these beauties. Yeah. Okay, for a, we just need to factor. Okay, factor first. It's asking us to simplify, so I need to see, do they have anything in common in the numerator and the denominator? Do not cancel out the x squareds. Do not, because it's not just x squared. It's x squared plus all of those items. Okay, it is a trinomial. You can cancel monomials, binomials if they are identical, trinomials if they are identical, not pieces of it. Okay. All right, so the numerator factors to be x plus 4, x minus 2, and in the denominator, we end up with x plus 3, whoopsies, times x plus 1. They don't have any factors in common, so dun dun dun. Okay, we're done. Super easy, right? All right, looking at B, it looks super scary. I'm fully aware. I'm about to break this down for you, so it is not super scary. Sorry, that is my son. He promised he would be quiet. Okay, so, oh golly. Buddy, Daddy is coming and Mommy is recording. Okay? Okay, sorry. So in the numerator, you have a fraction, and in the denominator, you have a fraction. Okay, try not to look at it as a line over a line over a line over a line, because that's a little wicked. So in that numerator, I want you to put parentheses around that fraction. In the denominator, I want you to put parentheses around that fraction so that you can see it is just one fraction being divided by another. That's all fractions are, is division. So then I'd like you to get into the habit of writing it expanded out. So I have that numerator being divided by the denominator. And why? Because this is a lot easier for us to comprehend, and when we look at it, than a fraction over a fraction over a fraction. That just gets weird. All right. So then what I'd like for you to do is at this time either keep, change, flip, keep the first fraction, change to multiplication, take the reciprocal of the second, and then simplify. Or simplify and then flip. I personally am going to flip it. So we have 5a squared minus 20 over 2a plus 2 times 4a over 10a minus 20. And then I'm going to simplify. So in the numerator, I can take out a 5, that's the GCF, and we get a squared minus 4 all over the GCF of 2 times a plus 1 times 4a all over 10 is the GCF, and then you have a minus 2. But we're not done, because a squared minus 4 is a difference of squares. Be careful. You need to make sure that you have factored completely. Otherwise, you will miss something that could potentially be canceled with the denominator, be it a GCF or a factor. Okay, so I factored that out to be a minus 2a plus 2. And then what I'm doing is I'm going to write my numerator as 1 and my denominator as 1 so that I can see what I'm going to cancel or reduce. All right, the 5 can reduce with the 10. Notice again, I'm using a different color so that I can see what I've canceled, what I haven't. The a minus 2's can definitely reduce to 1. And it looks like we have canceled everything. Now at the very end, I'm going to check just to make sure. Okay, so in the numerator, 2 is my only constant. I have an a, and then we have an a plus 2. And in the denominator, it looks like we have a 2 and then, oh, an a plus 1. Now I'm going to ask myself if there's anything else I can reduce. And there was. There was a 2. Okay, so we'll reduce that. And I think now we're done. So my final answer is going to be a times a plus 2 all over a plus 1. Okay, so remember with these complex fractions, yeah, in a way they are, but with these fractions over a fraction, acknowledge the numerator by putting parentheses around it, same with the denominator, and then write it expanded out so that then you can look at it a little bit easier than everything compounded on top of each other. All right, do me a favor, pause the video, try these on your own. Just like I talked about yesterday with the homework. Give yourself the chance to try it. Don't just look at the answers. Okay, pause. All right, welcome back. Hopefully you did pause it. These are a little bit more intricate than the first section, so I'm going to go ahead and just write out what I would do. So I'm going to simplify the top and the bottom. I'm also going to change to multiplication and take the reciprocal of the right-hand side. When you cancel or reduce, it looks like that's it. So our final answer should be in the numerator y plus 2, y minus 5 all over y squared times y minus 2. And it does say to simplify, so do not multiply the binomials. Do not multiply everything back together. That's pointless. Okay, if we're asked to simplify, leave it in simplified form. Okay, for B, I'm going to do what we talked about and acknowledge that there is that fraction in the numerator, there is that fraction in the denominator, and then I'm going to write it out. So I have 8x squared minus 72 over 5x plus 10 divided by 4x minus 12 over 5x. I'm going to factor out an 8, and that leaves me with x squared minus 9, so x plus 3, x minus 3 all over 5 is the GCF, x plus 2, change to multiplication, almost there, and 5x in the numerator, factor out the 4, x minus 3. I don't need that extra parenthesis. Sorry guys, don't really know why I did that. Okay, and then we're going to cancel. So the x minus 3s can reduce, the 5s can reduce, and the 4 and the 8 can reduce. Again, use a different color. Use tactics that are going to make your life a little bit easier. So in the numerator, we have a 2, we have an x, and we have an x plus 3. And in the denominator, it looks like we just have an x plus 2. And it doesn't appear there's anything else for us to simplify. You cannot simplify the lone x with the x in the denominator because the x in the denominator is a binomial. So that's our final answer. All right, guys, your homework that goes along with this is skill 1, and a part of skill 2, you have your assignment sheets. Get to work. I'll see you tomorrow.